let me help you work through open Stax 61 and 62 here. We're asked to complete the changes in concentration or pressure for each of the following reactions. This is nothing more than doing a mole-to-mole conversion. Let me show you just once or twice how to do it long way, and then we'll do it the short way using the ice tables. So basically we have X moles of oxygen here, and what we want to do is to convert that to moles of SO2. So we're basically converting from moles of O2 to moles of SO2. And what you'll see is that the moles of oxygen cancel, and we're left with 2x moles of SO2. Okay. Now a shorthand way of doing that is simply just to look at the coefficient. There's a 2 here, so we write plus 2x. All right. Over here we have a 2 as well, but this is on the other side of the equilibrium. So if we draw a double line through the equilibrium arrow, we have pluses all on one side, minus on the other. Okay. Now here in this problem we have 0.125. So under SO2 it's 2x, so I'm going to multiply 0.125 by 2. And that is going to be 0.250 molarity. Okay, I'll put a little plus sign in front of that to be very clear. On the other side of the equation we have minus 0.250 molarity. Okay. Here we've got 3x, and there's a 3 here for the coefficient in front of oxygen. So I'll put a plus in front of that. This is going to be plus 4x. On the right side I'm going to have minus 2x, and on the right side I'm going to have minus 6x. All right, those come from the coefficients. Now here you might be a little bit confused. So again, 3x is going to be equal to 0.24 molar. So x is going to be 0.24 divided by 3, or 0.080. Okay? So I'll just leave the units there. Now, we could go ahead and just use those same coefficients. So under ammonia, it's 4x. So 4 times that is going to be plus 0.32 molar. And I'll just go ahead and work that out over here in case you're a little bit confused about where that came from. 4x is equal to 4 times 0.080, which is 0.32. So we just go ahead and use that x here to calculate under nitrogen. It's minus 2x, or minus 2 times 0.08, which is 0.16. Under water vapor or steam, we have minus 6x, so 0.08 times 6 is minus, right, 0.48. So you'll see how we have plus x's or plus amounts all on the left, and minus x's or minus amounts all on the right. Here the coefficient is 1. It's not shown, but there's one C2H2 gas. So that's going to be x. I'll just put a plus there to be really clear about that. This is going to be plus 3x, and this is going to be minus 2x. Okay? If x is 25, what's 25 times 3? That's 75. On the right, we have minus 2x, or minus 50. Here we've got x. I'll put a plus there just to be really clear. Put a double line on the equilibrium so we can divide this table in half. So that's going to be plus x, and minus 3x. Here we have 5. X is 5. So that's going to be plus 5 atmospheres over here. It's going to be minus 5 atmospheres over here. And this is going to be minus 3 times that, or minus 15 atmospheres. Okay. In this problem, there is no solid amounts like molarity or something that's useful for equilibrium. So we have x, that's going to be plus x, and if the amount's plus 1.03 times 10 to the minus fourth, that's going to be plus 1.03 times 10 to the minus fourth. In this problem, once again, we don't have solids in equilibrium. We have 4x here. That's going to be minus x on the other side of the equilibrium. This is 0.40 atmospheres. So you might have to do a little bit of math here to do this. X is equal to 0.10 atmospheres. And so we have minus x, so that's just going to be minus 0.10 atmospheres. Moving on to number 62, same kind of situation. Divide the table in half. We've got plus 2x on the right, so we're going to have minus x, because there's just a 1 there, and minus 2x, because there's a 2 here. Now 2x is 1.5, so that means x is equal to 0.750 atmospheres. Notice how I'm keeping 3 sig figs there. So on the left, we're going to have minus 0.750 molarity. I'm not sure why I put atmospheres. That should be molarity. Let's erase that and fix it. And this is going to be minus 1.50 molarity. All right, so we've got x here. Let's divide the table in half. We're going to have plus 4x here because of the 4. We're going to have minus x, minus because it's on the other side of the equilibrium, and minus 2x. X is 0.020, so we can just fill in these values. 2 times that, okay, is minus 0.040. It's negative still on the right. On the left, we have plus 4x, so that's going to be plus, okay, 4 times 2 is 8, so that's 0.080 molar. Number 13, we've got x right here. I'm going to put a plus here, divide the equation in half. It's going to be plus x right here and minus 2x. So if x is 1.50, that's going to be plus 1.50 atmospheres. This is going to be negative twice that. 1.5 times 2 is 3.00. Plus x underwater. So, here, there's a coefficient of 3, okay? So we're dividing everything by 3. Normally you would think, well, that should be plus 3x because we have 3 in front of the H2O. But somebody said, well, we're going to divide that by 3 and just make that simply x. So what you would normally think over here is going to be divided by 3. So we're going to take everything we would normally think and divide it by 3. Let's go ahead and do that. Pretend like we had 3x here. That would be plus x here and plus 2x. And this would be, minus 2x and minus 2x. But we don't have 3x. We have 1/3 of that to get x, so this is going to be 1/3 of x, or x over 3. Okay, this is minus 2x, but we need to divide that by 3, so this is going to be minus 2/3 x, and this is going to be the same, minus 2/3 x. Okay. All right. Now for this one, we can kind of do what we want, okay? 3x is equal to 60.6 torrs, and that's what I want to do because that's how my mind works. I'm going to start out with the 3x. So let's go ahead and change the pen color back to black here. I'm going to create this problem right here that I'm boxing up is completely independent of the previous one. So normally I would think I would have 3x, and I'm going to use these blue values down here, right? 3x underneath that column is equal to 60.6 torrs. And so x is going to be equal to 20.2 torr, okay? And then I'm going to use this x here as a tool, plug it back into these blue, expressions to get all of the answers, all right? So if it's plus x, it's going to be plus 20.2 torrs. If it's minus 2x, it's going to be minus 40.4. If it's minus 2x, it's going to be minus 40.4. Okay, that's how you do that one. Next, again, we don't have solids in the equilibrium. We have x, and we have x. So if x is 9.8 times 10 to the minus 6, it's going to be plus 9.8 times 10 to the minus 6 molarity. Okay. Solids don't enter into the equilibrium. Here we have plus x. On the other side of the equilibrium, minus 5x. And 0.012 times 5 would be 0.06 atmospheres. So I hope that helps you solve this problem. Like the video, subscribe if this is useful for you. Thank